Let's move on now to finding out what triangular numbers are. So there's a few different ways to find out what triangular numbers are, and mostly we're going to work with square numbers. But in this case, I just want to show what a few triangular numbers are to start with. So what I've got here are just some little blocks, some math blocks. We're going to take these and just try and figure out what all the triangular numbers are. I'm just going to use this to lay these on. So my first triangular number we can see here is 3, because literally if I arrange these blocks, they make what appears to be a triangle. Okay? If I tried that with the number 4, you can clearly see it's not a triangle, it's a square. If I tried that with the number 5, see there's 5 blocks in that one. Well, I've got 5 blocks and they're kind of in a triangle, except it's not filled in the middle. So we're not going to call 5 a triangular number. If I try the same thing with 6, however, I can see that. So this represents 6 right here. Again, I've got myself a triangle. Okay, so 6 is a triangular number. I can arrange 6 pieces into a triangle. Okay, that's completely filled in. My next biggest triangular number is 10. I can arrange that into a triangle. And my next biggest triangular number is 15. There's 15 squares in that one. I can arrange that into a triangular number. So if we're looking to find what all of the triangular numbers are, I mean, I suppose we could take math blocks and simply just start putting blocks together and counting them. But that's really not the best way to do this. So I'm just going to start out with all my triangular numbers that I've done so far, and then we're going to find a pattern to find all the rest of the triangular numbers. And there's an infinite amount. So we know that 3 is a triangular number. We know that 6 is a triangular number. We know that 10 is a triangular number, and 15. So if you look for a relationship between all of these numbers, what you'll find is that by simply adding 3, you find 6. Then by adding 4, you make 10. By adding 5, you make 15. So you can see that every time we do this, we're adding, or we're going up by one more number. So 3 plus 3 equals 6. Then 6 plus 4 equals 10. Then 10 plus 5 equals 15. So it stands to reason that our next triangular number is going to be plus 6, and that will equal 21. Our next triangular number would be 21 plus 7, and that would equal 28. Our next triangular number is 28 plus 8, and that's 36, and 36 happens to be a square number and a triangular number. Our next one would be 36 plus 9, which is 45. And I'll just go one more. We'll do 45 plus 10 equals 55. So basically what we've done here is we've listed off all of our triangular numbers between 1 and 50, or between 1 and 60. Okay? There's one more really neat thing that you can do with triangular numbers, and that is I can always take my triangular numbers and combine them to make a perfect square. So if I go back here, I'm just going to relist all of my perfect squares between 1 and 100, and I'm going to list all of my triangular numbers between 1 and 60. So the perfect squares were 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And then if I go back to my triangular numbers, well, they were 3, 6, 10, 15, 21, 28, 36, 45, and 55. Those are all triangular numbers. What I want to prove to you is that I can take my triangular numbers, and if I take any 2 that are beside each other in this list, I can always make those 2 into a square number. Triangular numbers always combine to make a square number. So let me give you an example. If we use 3 and 6, okay, I can take those 2 numbers. So here's my 3, here's my 6. And if I flip this 6 around, you see that they actually fit together and they form a square. So the triangular number 3 combined with the triangular number 6 makes the perfect square, or the square number, 9. So you can see that those 2 together make 9. Then I can try this again. What if I tried the triangular number 6 with the triangular number 10? Again, I can just flip one of them around. They squeeze together, fit together, and you can see that again, they make a perfect square. This time it happens to be 4 times 4, so you know there's 16 squares there. So if I separate those out, I can see that 6 and 10 come together to make 16. You can also see that 10 and 15 come together to make the perfect square, 25. So these two together combine to make 25. And it's kind of a neat relationship. We don't really need to work with triangular numbers too much. Mostly we use square numbers in this chapter. But it's kind of interesting to know, and you might be asked on a test, how the triangular numbers relate to the square numbers.